Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It is useful for recalling when exam coming man student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Computer Hardware and Networking, 17,533. These are mostly important questions which is always repeat. Form top to end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Computer Hardware and Networking Chapter 5. 1. 1. Compare between OSI and TCP/IP reference model. Any 6 points, 1 m each point. 2. Describe data encapsulation, diagram -2m, explanation -2m, in figure, which gives an overall view of the OSI layers. D7 means the data unit at layer 7, D6 means the data unit at layer 6, and so on. The process starts at layer 7, the application layer, then moves from layer to layer in descending, sequential order. At each layer, a header, or possibly a trailer, can be added to the data unit. Commonly the trailer is added only at layer 2. When the formatted data unit passes through the physical layer, layer 1, it is changed into an electromagnetic signal and transported along a physical link. Upon reaching its destination, the signal passes into layer 1 and is transformed back into digital form. The data units then moves back up through the OSI layers. As each block of data reaches the next higher layer, the headers and trailers attached to it at the corresponding sending layer are removed. And actions appropriate to that layer are taken. By the time it reaches layer 7, the message is again in a form appropriate to the application, and is made available to the recipient. Encapsulation figure reveals another aspect of data communications in the OSI model, encapsulation. A packet, header in data, at level 7 is encapsulated in a packet at level 6. The whole packet at level 6 is encapsulated in a packet at level 5, and so on. In other words, the data portion of a packet at level 5, and so on. In other words, the data portion of a packet at level N1 carries the whole packet, data, and header, and maybe trailer, from level N. The concept is called encapsulation. Level N1 is not aware of which part of the encapsulated packet is data, and which part is the header or trailer. For level N1, the whole packet coming from level N is treated as one integral unit. Computer Hardware and Networking Chapter 5. 2. 3. Explain following terms. I. Subnet masking 2. ARP3. FTP4. IP address classes. Each term 2MI. Subnet mask. Subnet mask is a 32-bit number associated with an IP address. It allows the user to identify which part of an IP address is reserved for the network, and which part is available for the host. A bit with 1 in the mask indicates the corresponding bit in the IP address is a part of the network identifier, while a bit with 0 in the mask indicates the corresponding bit in the IP address is a part of the host identifier. Default subnet mask for different classes are as given below. Class A, 255.0.0.0. Class B, 255.255.0.0. Class C, 255.255.255.0 e.g., 255.255.255.0 implies that 24 bits are used for networking and 8 bits for hosts, and it is the default subnet mask for Class C IP addresses. 2. Address Resolution Protocol, ARP. Address Resolution Protocol provides IP address to MAC address resolution for IP. Packets. The Address Resolution Protocol, ARP, can determine the physical address used by the device containing the IP address. ARP maintains tables of address resolution data and can broadcast packets to discover addresses on the network segment or use previously cached entries. The physical addresses discovered by ARP can be provided to data link layer protocols. All addresses in the ARP table are only local addresses. 3. File Transfer Protocol, FTP. The File Transfer Protocol, FTP, is a protocol for sharing files between networked computer hardware and networking. Chapter 5. 3. Hosts. FTP enables users to log on to remote hosts. Logged-on users can inspect directories, manipulate files, execute commands, and perform other commands on the host. FTP also has the capability of transferring files between dissimilar hosts by supporting a file request structure that is independent of specific operating systems. 4. IP address classes. There are currently A, B, C, D, and E classes of addresses in IPv4. The unique address given to a machine is derived from the class A, B, or C addresses. Class D addresses are used for combining machines into one functional group, i.e., multicasting, and Class E addresses are considered experimental for research and are not currently available. 4. Why UDP protocol is used. UDP-2M. UDP is User Datagram Protocol. It is connectionless protocol because data is sent without establishing a connection between sender and receiver before sending the data. UDP is unreliable because data is delivered without acknowledgement. UDP does not perform auto-retransmission. UDP does not use flow control. UDP has high transmission speed. Computer Hardware and Networking. Chapter 5. 4. 5. Give function of each layer of OSI reference model. Brief description of each layer. 3M, OSI model, Open System Interconnection. Model was developed by ISO, International Standard Organization. Function of OSI model. It provides way to understand how internetwork operates. 2. It gives guideline for creating network standard. OSI model has 7 layers as shown in the figure. OSI model has following 7 layers as physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. 1. Physical layer. It coordinates the functions required to transmit bit stream over physical medium. It deals with mechanical and electrical specifications of interface and transmission medium. For transmission, it defines procedures and functions that devices and transmission medium has to perform physical characteristics of interfaces and media. Representation of bits, data rate, transmission rate. Synchronization of bits. Line configuration. Point-to-point or multipoint configuration should be used. 2. Data link layer. It is responsible for transmitting group of bits between the adjacent nodes. The group of bits is called as frame. The network layer passes a data unit to the data link layer. Header and trailer is added to the data unit by data link layer. This data unit is passed to the physical layer. Data link layer is responsible for moving frames from one node to the next. Functions of data link layer are 1. Framing 2, physical addressing 3, flow control 4, error control 5, media access control 6, node-to-node delivery 3. Network layer. It is responsible for routing the packets within the subnet, i.e. from source to destination. It is responsible for source E to destination delivery of individual packets across multiple networks. It ensures that packet is delivered from point of origin to destination. Functions of network layer. 1. Logical addressing 2. Routing. 3. Congestion control 4. Accounting and billing 5. Address transformation 6. Source host 2. Destination host error-free delivery of packet. 4. Transport layer. Responsibility of process-to-process delivery of message ensure that whole message arrives in order. Functions of transport layer: 1. Service point addressing. 2. Segmentation and reassembly. 3. Connection control. 4. Flow control. Flow control is performed end-to. Computer hardware and networking. Chapter 5. 5. End 5. Error control. 5. Session layer establishes, maintains, and synchronizes the interaction among communication systems. It is responsible for dialogue control and synchronization. Functions of session layer: 1. Dialogue control. 2. Synchronization, session, and subsession. 3. Session closure. 6. Presentation layer. It is concerned with syntax, semantics of information exchanged between the two systems. Functions of presentation layer: translation. Presentation layer is responsible for converting various formats into required format of the recipient. Encryption, data encryption, and decryption is done by presentation layer for security. Compression and decompression, data to be transformed compressed while sending and decompress while receiving for reducing time of transmission. 7. Application layer. It enables user to access the network. It provides user interfaces and support for services like email, remote file access. Functions of application layer: network virtual terminal, file transfer access, and management, mail services, and directory services. D. Explain the different classes of IP addressing. Explanation. Class 3M. Class A addressing. 1. First byte specifies the network portion. 2. Remaining bytes specify the host portion. 3. The highest order bit of the network byte is always 0. 4. Network values of 0 and 127 are reserved. There are 126 Class A networks. 5. There are more than 16 million host values for each Class A network. Class B addressing. 1. The first 2 bytes specifies the network portion. 2. The last 2 bytes specify the host portion. 3. The highest order bit 6 and 7 of the network portion are 10. 4. There are more than 16,000 Class B network. 5. There are 65,000 nodes in each Class B network. Class C addressing. 1. The first 3 bytes specifies the network portion. 2. The last bytes specify the host portion. 3. The highest order bit 5, 6 and 7 of the network portion are 110. 4. There are more than 2 million Class C network. 5. There are 254 nodes in each Class C network. Class D addressing. 1. Class D address defines a group ID and used for multicasting. Computer hardware and networking. Chapter 5. 6. 2. Internet authorities have designated some multicast address to specific groups. Class E addressing. Fig show address format of Class E addressing. This format begins with 1110 that show it is reversed for the future use. I draw TCP/IP reference model and give the function of each layer. ANS 2M diagram for M explanation 1M each layer, or as we can see from the above figure, presentation and session layers are not there in TCP/IP model. Also note that the network access layer in TCP/IP model combines the functions of data link layer and physical layer. Layer 4. Application layer. Application layer is the topmost layer of 4-layer TCP/IP model. Application layer is present on the top of the transport layer. Application layer defines TCP/IP application protocols and how host programs interface with transport layer services to use the network. Application layer includes all the higher-level protocols like DNS, Domain Naming System, HTTP, Hypertext Transfer Protocol, Telnet, SSH, FTP, File Transfer Protocol, TFTP, Trivial File Transfer Protocol, SNMP, Simple Network Management Protocol, SMTP, Simple Mail Transfer Protocol, DHCP, Dynamic Host Configuration Protocol, X Windows, RDP, Remote Desktop Protocol, etc. Layer 3. Transport Layer. Transport layer is the third layer of the four-layer TCP/IP model. The position of the transport layer is between application layer and internet layer. The purpose of transport layer is to permit devices on the source and destination hosts to carry on a conversation. Transport layer defines the level of service and status of the connection used when transporting data. The main protocols included at transport layer are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Layer 2. Internet Layer. Computer Hardware and Networking Chapter 5. 7. Internet Layer is the second layer of the four-layer TCP/IP model. The position of Internet Layer is between Network Access Layer and Transport Layer. Internet Layer pack data into data packets known as IP datagrams, which contain source and destination address, logical address, or IP address, information that is used to forward the datagrams between hosts and across networks. The Internet Layer is also responsible for routing of IP datagrams. Packet switching network depends upon a connectionless internetwork layer. This layer is known as Internet Layer. Its job is to allow hosts to insert packets into any network and have them to deliver independently to the destination. At the destination side, data packets may appear in a different order than they were sent. It is the job of the higher layers to rearrange them in order to deliver them to proper network applications operating at the application layer. The main protocols included at Internet Layer are IP, Internet Protocol, ICMP, Internet Control, Message Protocol, ARP, Address Resolution Protocol, RARP, Reverse Address Resolution Protocol, and IGMP, Internet Group Management Protocol. Layer 1. Network Access Layer. Network Access Layer is the first layer of the four-layer TCP/IP model. Network Access Layer defines details of how data is physically sent through the network, including how bits are electrically or optically signaled by hardware devices that interface directly with a network medium, such as coaxial cable, optical fiber, or twisted pair copper wire. The protocols included in Network Access Layer are Ethernet, Token Ring, FDDI, X.25, Frame Relay, etc. Computer Hardware and Networking Chapter 5. 8. D. Describe the need and importance of subnet masking. Give an example of subnet mask. ANS, 2M explanation, 2M example. Subnet mask is a 32 bits long address used to distinguish between network address and host address in IP address. Subnet mask is always used with IP address. Subnet mask has only one purpose, to identify which part of an IP address is network address and which part is host address. With subnetting, IP addresses use a three-layer hierarchy. Network subnet host improves efficiency of IP addresses by not consuming an entire address space for each physical network. Reduces router complexity. Since external routers do not know about subnetting, the complexity of routing tables at external routers is reduced. Note, length of the subnet mask need not be identical at all subnetworks. For example, how will we figure out network partition and host partition from IP address 192.168.1.10? Here we need subnet mask to get details about network address and host. Address. In decimal notation, subnet mask value 1 to 255 represent network address, and value 0, 0, represent host address. In binary notation, subnet mask on bit 1 represent network address, while off bit 0 represent host address. In decimal notation, IP address 192.168.1.10, subnet mask 255.255.255.0, network address is 192.168.1, and host address is 10. In binary notation, IP address 11000000.1000000001.0000001.0000010, subnet mask 1111. Network address is 11000000.10101000000001, and host address is 00001010. A. State the step-by-step procedure for installation of TCP/IP protocol and configuring the same. ANS, the various basic and advanced properties configured for TCP/IP. You can use this procedure to configure the TCP/IP settings for each of your network connections. Each connection can be configured to use IPv4 or IPv6, or both. To configure TCP/IPv4, open the Network Connections folder and view available connections. 2. Right-click the connection that you want to configure, and then click Properties. 3. Do one of the following. If the connection is a local area connection, on the General Computer Hardware and Networking Chapter 5. 9. Tab in this connection uses the following items. Click Internet Protocol version 4, TCP/IPv4, and then click Properties. If the connection is a dial-up, VPN, or broadband connection, on the Networking tab. In this connection uses the following items. Click Internet Protocol version 4, TCP/IPv4, and then click Properties. If the connection is an incoming connection, see Configure an incoming connection to use TCP/IP. 4. Do one of the following. If you want IP settings to be assigned automatically by a DHCP server, VPN server, or other device that provides DHCP services that is installed on the network to which you're connecting, click Obtain an IP address automatically, and then click OK. If you want to specify an IPv4 address, or a domain name service, DNS, server address, do the following. Click Use the following IP address, and then in IP address, type the IP address, and an appropriate subnet mask and default gateway address. Click Use the following DNS server addresses, and then in Preferred DNS Server and Alternate DNS Server, type the addresses of the primary and secondary DNS servers. 5. To configure DNS, Windows Internet Name Service, WINS, and IP settings, click Advanced. 6. On a local area connection, selecting the Obtain an IP address automatically option enables the Alternate Configuration tab. Use this to enter alternate IP settings if your computer is used on more than one network. To configure DNS, WINS, and IP settings, click User Configured on the Alternate Configuration tab. E. Compare TCP and UDP. For points, ANS.